new. So the last couple of days, we have been comparing fractions. And when we do that, we've been making two separate wholes. So for instance, if I was comparing the fractions 1/2 and 2/4, I would make a bar or a number line for 1/2, and then I would make one for 2/4. If the fraction is talking about the same whole, I can layer it. What does that word layer mean? What does that word layer mean? We don't know. We never heard that word before. What does that word layer mean? Heidi, what does layer mean?
It means like putting stuff on top.
Yeah, we're going to be putting things on top of each other. So I need you to write down as your title, you can layer your number lines so that different fractions are on one number line. Go ahead and write that sentence as your title. We're going to start out with two number lines. Put your notebook on your desk. So go ahead and draw two number lines underneath, and then I'll show you how to do it on one in a moment. I'll give you some seconds to write that since I know that is a long sentence. So we've got our two number lines drawn. We know that both of these number lines are going to go from 0 to 1. Go ahead and label them. That first number line, I'm going to label 1/2. Go ahead and label your first number line 1/2. That should be pretty easy peasy. My second number line, I'm going to be partitioning. Partitioning just means cutting up. Partitioning into fourths. How many pieces do I need if I'm counting by fourths?
I count spaces or lines.
You tell me.
Lines.
No.
Spaces.
All of it. Mackenzie, how many spaces, how many pieces do I need if I'm counting by fourths? 4. I'll start in half first. And then half of a half. Half of a half. I can count my spaces. 1, 2, 3, 4. You can easily tell where 2/4 is going to go. Yes? Yes. All right, so now we're going to talk about this layering thing. Underneath these two number lines, draw one more number line. On that number line, watch what's going to happen. I'm going to line up, which I know you can't move yours, but I'm going to move my number line right on top. You see how I did that? So now, on your new number line, you're going to label 1/4, 2/4, and 1/2. Remember to stack them, because when things are stacked, that shows that they're equal. And 3/4. So even though I have two different fractions, I have halves and fourths, I can still put them on the same number line. Do you see how I did that? Sometimes we'll see fractions with different denominators stuck on the same number line. Yes? You could just do 1/1. So far, so good. This makes sense. Okay. We're going to do another one. You don't need to rewrite the words, but I do need the fractions. We're going to be looking at 1/3 and 2/6. Go ahead and write the two fractions and draw two number lines. We're going to separate them and then we'll smush them together in a moment.
I'm gonna do it right now.
No, we're going to do them separate first. So my first number line, if I want it to show thirds, how many pieces do I need on that number line if I'm going 0 to 1? I'm going to wait till I see every single person's hand. On that first number line, if I'm showing thirds, how many pieces do I need? I'm waiting until I see every person's hand.
You know what I'm doing.
So if you are not raising your hand to answer, I need you to stop doing what you're doing and think about my question, please.
Trying to get the number I'm doing.
Actually, how many pieces do I need? 3. Go ahead and partition that first number line into thirds. So far, so good. If I'm showing 6 on my second line, or second number line, how many pieces am I going to partition it into? Kinsey?
What was your question?
How many pieces am I partitioning the second number line into?
6.
6. Go ahead and partition it into 6. So far, so good? Okay. Draw another number line, and we're going to put 6 and thirds on the same one. So on my number line, all I'm going to do is smush them together. Just like that. So your final number line, you can go ahead and partition them all the way into 6. And then we have some places where they overlap. What's one place where my thirds and 6 overlap? When I layered my number line, where did they overlap? Where's your third number line that I asked for? Zach?
It's at the 1/3.
Yeah, at the 1/3 and 2/6. Those are at the same spot, so they overlap. Is there another place where they overlap? If you're not looking at your number line, it's going to be really hard for you to answer that question. Draw a third number line. There's another spot where they overlap. Look at your book. Where else did they overlap? Jalen?
They overlapped at 4/6 and 2/3.
Yeah, 2/3 is at the exact same spot as 4/6. So far, so good. Do we understand that they're just overlapping? Could I, if I just saw this, could I break them into 2 separate number lines?
Yes.
Yes. I can leave them layered, or I can separate them. Colby?
Don't one whole kind of overlap too?
Yes.
It could be one whole or 6/6.
Yes. Or 3/3.
Or does zero overlap kind of?
Yep. Evelyn? I don't know if you're going to be able to move them because it's on the computer. I don't know if they're going to let you have that feature. But you'll have paper, so you could draw it for sure. I don't know if the computer will let you. I don't know. But you will absolutely have paper, and you could absolutely draw it. So far, so good? We've got one more. Go ahead and draw your 3 number lines, because we're going to put them separate on 2, and then you're going to combine them on that last one. This time we're looking at 8s and 4ths. Yes, I know. Your first number line, go ahead and partition into 8s. Your second number line, partition into 4ths. You can definitely do that part. Remember, if I'm dealing with even numbered denominators, I can split in half first. If I'm doing 8s, I can do halves again, and then halves again. Oh, that got really crazy. When you put them on the same number line, what was one point that overlapped? When you put them on the same number line, what was one point that overlapped? Brianna?
It looks like 2 8s and 1 6.
One what? What are we counting by on that second one?
I mean, and 2 8s and 1 4.
2 8s and 1 4. What does it mean when 2 fractions are overlapped like that? What does that tell me? What does that mean when those 2 fractions are overlapping? Gio, what do you think?
It tells you the overlapping. It tells you if they're equivalent.
Yeah. If they are overlapping, they're equal. That's what that means. They take up the same amount of space. Do they look the same? Nope. But they take up the same amount of space. What other equivalent fractions do we see? What other equivalent fractions do we see? If you're sitting there not raising your hand, you're part of the problem. Carl?
4 8 equals to 2 4s.
4 8s is equal to 2 4s. Carl knows that because they take up the same spot. They overlap at the same spot. There's one more. Actually, there's a couple more. What else is an equivalent fraction or pairs of equivalent fractions? Ariana? Yep, Gia already gave us that one. Can you find a different one? 6 8s and 3 4ths. There's another one. Zach?
8 8s and 4 4s.
8 8s and 4 4ths. There's another one. Can you find it? It's a little tricky because I didn't write it in fraction form. Where else would it overlap? John, playing with your tissue doesn't help you answer any of those questions. Macklin, do you think you find it? Yeah, 0 eighths is equal to 0 fourths. 0 is equal to 0. Yes? All right. All right. So we're going to spend some time talking and looking at fractions that are different, that are on the same number line. This is like the trickiest part of fractions. Everything else that we've done so far, you guys are doing great. This is where it can get a little tricky because we've got different fractions happening on the same number line, that layering piece. Yes? Nope, we're not doing that. Let's focus on what we're doing, please. Turn to the next blank page. Turn to the next blank page, please. Go ahead and title that with that sentence. It says, knowing a fraction's size can help you place different fractions on a number line. So we've got a lot of different fractions there. You're going to be writing all 5 of those fractions down once you write that sentence, because we're going to put all 5 of those different fractions on the same number line. All right. Which of these fractions do you already know where it goes? I bet you could figure out where one of them goes. Start with the easies. Where is it going to go? Where is it going to go? Jalen?
1/2 could go in the middle.
Okay. Let's put 1/2 in the middle. That makes sense. 1/2 usually shows up in the middle. So I'm going to cross out 1/2. I got 1/2. All right, if 1/2's in the middle, could you find a home for something else? What other fraction could you figure out where it might go? Bryson?
0 can go at the beginning.
Yeah, let's put it. All right, we got that one done. Where else can we put a fraction? There's another. Well, there's put on there. Carl?
2 2's can be at the end.
How do I say that fraction? Because it's not pronounced 2 2's.
Oh, 2 halves.
2 halves. Where is it going to go?
At the end.
At the end. Because I have 1/2. So I can easily find where 2 halves is going to go. All right, now we're left with 1/3 and 1/6. Let's start with 1/6. Is 1/6 going to be bigger than 0? Yes. Is 1/6 going to be bigger than 1/2?
No.
No. So is 1/6 going to go over here?
No.
No. So we know it's going over here. Now we got to think about the piece size. Think about your 1/6 piece. Is that going to be a big piece or is it going to be a little piece? So is it going to go closer to 0? Or is it going to go closer to 1/2? Closer to 0. How about here? We think that's a good spot?
Yes.
Sure. Write it. 1/6 is not a big piece. Because you would need 6 of them to fill up your number line. Those pieces aren't going to be very big. Well, now let's think about 1/3. Is 1/3 bigger than 0?
Yes.
Yes. Is 1/3 bigger than 1/6?
Yes.
Okay, so it's not going in here. Is it bigger than 1/2?
No.
No. It's not bigger than 1/2. So it's got to go somewhere in here. Where is it going to go? Where is it going to go? Evelyn?
Well, I researched it.
Sure.
I did I did 1/3 first, and I knew that 1/6 was something.
Nice. Nice. So Evelyn says, okay, well, if 1/6 is that size, then I know 1/3 is about 2 of those. So 1/3 should be about there. Done. You just put 5 different fractions on that number line. 3 of them have different denominators. All you had to do was think about the size of the piece.
Wait, they're not equal size spaces.
They are not equal size. Is that okay?
Sort of in big
Yes.
spaces.
Could I put all the fractions on there where we could have equal size pieces?
Yes.
Yeah, I could. And they would overlap. But this shows fractions. Even though it looks like we have small pieces and medium pieces and big pieces, it's because those are different size pieces. And just erase some of the other stuff. Does that make sense? All right, we're going to try one more. I do not need you to write the sentence again. I just need you to write the fractions. And then a number line. Yep. We're going to put these 5 fractions on a new number line. Write it down.
I'm trying to make the spaces equal this time.
No, because they're not going to be equal because they're not showing the same fraction. You need to write the fractions down, please. All right, let's start out with easies. What would be an easy fraction for you to put on that number line? John, you got an easy fraction?
Yes. One whole.
One whole.
Because I've now got that.
One whole goes at the end.
Goes
Remember, this fraction, when I read it, is one whole. Thank you. So, what else could I put on this number line? Find the easies first. What else would go on that number line? Kaden?
1/8.
Where's that gonna go?
Really close to 0.
Alright, so let's put 0 first. Caden's like, we're gonna do 0 to 1. Caden thinks that 1/8 is really close to 0. Why? Why? Why would 1/8? It's got an 8 in it. That sounds big. Why would 1/8 be really close to 0? Kenzie?
Because they're smaller pieces.
Yeah, if I'm cutting something into 8 pieces, those pieces are going to be kind of small. When you play with your fraction pieces, are those the big ones or the little ones? The little ones. So Caden's exactly right. 1/8 is pretty close to 0. Those are really small pieces. What else could I put on the number line? Think about size. Imagine those pieces. Where would they go? Colby, what you thinking? 1/4. Where's 1/4 gonna go, you think?
Double the size of 1/8.
Oh, how'd you figure that out?
Just 2/8 is equal to 4.
Woo! Y'all hear that, genius? Say it one more time.
1/4 would be double the size of 1/8 because 2/8 is equal to 4.
Colby says, hey, I know that 2/8 is worth the same amount as 1/4. So I'm gonna take my fingers. I'm gonna say, okay, that's 1/8. So another 8 would be there. So that's about 1/4. Because 2/8 gives me to 1/4. I like it. We got 2/3 and we got 7/8 left. Where's that gonna go? One of those is really easy peasy for my brain. Huxley, where do you think 7/8 is gonna go? Why? I agree, but why?
2/8 goes before 1 whole.
Yep.
7 after 8, so then 7 would go after
Before.
4 before.
So Huxley says, well, I know 8/8 is equal to 1 whole, so 7/8 is going to be really close. Because a 1/8 piece to get me to that 8/8 is not very big. 7/8 is super close. What about 2/3? That one's kind of tricky. Where would 2/3 go? That one's tricky. It's only one piece away. So would it be really close to 1?
No, not necessarily.
Kinda. But remember, our third pieces, Mackenzie, are pretty big. So it's not going to go super close to 1 whole, because we got to fit a whole third piece in there. Zach, what you thinking?
Like 2 more fingers away from the
So, you think it's here?
Not the middle, I think. The mid. No.
Let's do this. Let's put an easy fraction that we can all find. Let's put 1/2 real quick. There's not equal to 1/2, but is it bigger or smaller than 1/2? Think about it. 1/2 is 2/3 going to be bigger or smaller?
Bigger.
Can that help us figure out where it's going to go?
Yes. Wait, it's 1/6 past.
It is 1/6
Past 1/6. Wait, so
It's 6 bigger, yeah.
Wait.
It is. So, is 2/3 going to go here?
Nope.
It's going to go on this side?
No.
No, because we know it's bigger than 1/2. So maybe here?
Yeah.
All right, flop it on your number line. Yeah, it would be close to 6/8. Please stop eating tissue. So far, so good. This can be tricky, but it's not tricky if we keep thinking about size of the pieces. All about that math logic that we've been practicing this week. So far, so good. Okay, here's what we're going to do. I have a comparison problem or page that you're going to do. Before we do it, I just want to write down these symbols. So if you have space in your notebook, just do a squiggle line. This won't take very much space. But I want to make sure we know our symbols. So the first symbol is one that we've used all year. What does that symbol mean? Yes. It's not going to take very long. What does that symbol mean? Jalen, what does that symbol mean?
It means that numbers on both sides are equal.
Okay, if I don't know what equal means, how do I know what equal means? Give me some different words in there. What does that symbol mean? We've been using that symbol all year. Ariana, what does that symbol mean? Okay. What does that mean? Yeah, we've got the same value. I'm writing, you're writing. We have two symbols to show that they're not the same.
The alligator symbol. What they call it, that's that.
I'm writing, you're writing. This first symbol shows that this first value is greater. The second symbol shows that this first value is less. So you're going to need to be writing each of these symbols Didn't we have that conversation in morning meeting? Didn't we have that conversation in morning meeting? You're going to need these symbols on your worksheet today because you're going to be comparing two fractions, and then you need to put the correct symbol in. Does this make sense? Easy peasy? If you need more space to draw your pictures, to draw your models, use the back. What?
Wait, is it